Just copy. Now this stuff. Okay. Anyways, so if you can paste the data there.
Mm-hmm.
Okay. So now what we are trying to do is this is the data for average handling time, or the tenure of people on in the team, or sorry, the average handling time clocked by people whose tenure is less than 1 year. Okay, and these data is in seconds,
Mm-hmm.
right? So what we want to find out, so imagine this is the data that you have and you want to set a target for the project. Okay, now how would you go ahead and do that? On what basis would you decide on the reduction target? So first thing we do whenever we want to check any data is we want to check if the data distribution is normal or not normal. And do you remember, Scott, how do we go ahead and do that?
You just is a basic stats normality test, right?
Yes, you can do normality test. So let's quickly do the test and you tell me if do you think it is normal, not normal.
I would say not normal.
Okay, why would you say that?
Well, P lower. Well, actually, the p-value says it's normal.
Yes,
No,
so
wait.
the p-value says it's normal, it means it is normal. So I think you're saying because there are data points, some of the
Aren't
data points
touching.
are farther away,
Right,
right?
right.
No, but then see, I've told you the ideal scenario. Ideal, if it's perfect normal distribution, then everything would be on the line, right? But
Okay.
there's nothing as perfect normal. It should be close to this line, running in the same sequence.
Okay.
So the data points are also flowing in the same sequence, right? But
Okay.
more robust way is to check the p-value. P is high, that means distribution is normal. So if it is normal, we are okay with the mean, right? So we can use
All
the
right.
mean based test now. So let's go to basic statistics, and rather, let's look at it from let's look the data in the graphical summary as well. So we go to graphical summary, click here, we got the p-value. It's the same value that we got there,
Mm-hmm.
right? P is high, that means
Yep.
distribution is normal. Okay, and we know the mean is 143.
Mm-hmm.
Okay, now do you want to reduce the direction of good is average handling time, the lower the better, right?
Right.
So what is the target? How would you know what is the target that you want to keep? You know that the mean is 143. What is the reduction? How much should be reduction? How would you decide that? Any guesses?
How would we decide? By the standard deviation?
Okay, by the standard deviation, you can, but you know how, how would you be able to calculate? Would you deduct one standard deviation from it?
Right. That's what I was thinking.
Right, but how would we know whether it is actually, uh, what is the distribution actually? Is there two standard deviation, one standard deviation that we can fit in, or so
Right.
there's the easier way of doing it. If you look here, 95% confidence interval for mean. See, distribution is
Okay.
normal, so you're looking at mean. If you look at 95% CF for mean,
Mm-hmm.
normally the process behaves between 122 to 164.
Okay.
Anything outside these boundary would be a significant target to be taken for the project. Since the direction of good is lower the better, let's take a target as 121.
Okay.
And let's see if it's a significant target. So for that you need to go to basic statistics, one sample T.
One sample T.
Okay, you click here, you would get the data that you have in Minitab.
Yeah.
Sorry, in the data sheet. You getting it?
I didn't get any data when I I closed that graph. Did I have to leave it open?
Nope.
Statistics
No, you don't.
basic. One sample T.
Yes, absolutely. One sample T. You getting something like this?
Yep. Oh, I had to click. Ha! That's all I had to do. I got it.
Yeah. Okay. One sample, click here, and then you do perform hypothesis test.
Okay.
Click on this checkbox. Now, hypothesized mean. So what is the mean that we thought? We thought we will take 121 as hypothesized mean. So let's enter 121 and go to options.
Okay.
So there are three things that you can check. So if your current mean, current sample is, so what you would check alternate hypothesis here, alternative here. So what we are checking right now, if it is not equal to the hypothesized mean, the current sample mean is not equal to hypothesized mean. That is what we are checking right now.
Okay.
Okay, you can go to graphs as well and click on box plot of data. You done that?
Mm-hmm.
Click on OK. Okay, did you get it?
Yep.
Okay, so let's look at this box. It's the same box plot. Instead of vertical, it's horizontal. So you see this blue line?
Mm-hmm.
Blue line is that interval 122.75 to 164.472. The HO, which is, and okay, by the way, null hypothesis is also denoted as HO.
Okay.
So the null hypothesized mean that you have taken is 121. Okay, which is outside these blue lines. So that means it is a significant target to be taken, or this value, the hypothesized mean is significantly different than the sample mean. If you can minimize this and go to session window, expand that, directly look at p-value.
0.036. Yeah.
Right. So remember, which hypothesis is this? Would it be null or alternate?
No.
I'm sorry?
It would be alternate.
Alternate. And what does alternate mean? There is a difference.
It's good. Yes.
Yeah.
There is a difference.
No, there is a difference, right? So there is a significant difference between the hypothesized mean and the sample mean. Hence, because it is different, we can take it as a significant. So that means this target of 121 is statistically significant target to be taken for the project. Okay. So if we go by this logic, ideally, if we go by this logic, and if we take any targeted value within these points here, between 122 and 164, in that case, p-value should ideally come as greater than 0.05.
Right.
I mean, it should be null hypothesis. So why don't you go ahead and try that? So I'll tell you a shortcut. Can you see this icon?
Let's see. I got a whole bunch of them up there. Edit last time. Mine's a little different.
It must be somewhere over there.
LS, okay. Got it. Got it.
Okay.
Looks just a little different, but
okay. So it'll directly take you there, and you can simply change the hypothesized mean from here. right? So choose any value between that range, 95% CI range. Okay, what is the value that you entered?
I put 123.
123. So
Which
ideally
puts
it
it right
should
on
be
the
very
low
near.
end.
Right. See, it is coming. It has come on that blue line.
Mm-hmm.
See, it is greater than 0.05. No, borderline case, but
Yep.
then greater than 0.05. That means
Which
null.
makes sense. We were right beside it. Yeah.
Right. Null hypothesis. That means there is no significant difference between hypothesized mean and the sample mean. Hence, it will not be advisable to take this mean of 123 as a targeted mean for the project.
Mm-hmm.
Okay, so this is
Okay.
one sample t-test. So what you're trying to do here, you're trying to compare the sample mean with the targeted value or a standard value. So generally, this test is used whenever we want to set target in the project.
Okay.
Universally, this test is applicable for target setting. So, even in the pharmaceutical industry, whenever they come out with a new drug, what they do is they do the clinical trials, and then they note down the chemical composition every time they do the trial, and then they do the one sample t-test to see if there is a significant difference between the value that they wanted and the value that trials have given them. Okay, and if it is null hypothesis in their case, then they release the drug. Otherwise, they keep on doing amending the composition. Okay, so that is one sample t-test. Now let me just first close it. Now, so same example of average handling time project. What we want to do is we want to compare. So there might be two supervisors, right? Supervisor A or supervisor B, or in the example that I have in the two sample T test data.
Mm-hmm.
So we have tenure of associates less than 1 year and tenure of associates greater than 1 year. So we want to see, if there is if tenure is a significant factor or not. Tenure
Okay.
or tenure of people working in the process, is it a significant factor or not? Okay, so what I'm doing is I'm copy pasting it here. I don't need to delete it. I can keep it like that. But I generally would want to delete it, otherwise I'll make the mess of it. So what we're trying to do, we have got two data set. One is associates or the agents who are less than 1 year of tenure, and the agents who are greater than 1 year of tenure. And one of the factors that we got during brainstorming is that the tenure of the agent is actually impacting on the average handling time. So somebody is saying, people with less tenure or people with more tenure are taking less amount of time. So we want to prove that. So we collected data for that, and we want to see whether tenure is actually impacting or not. Okay, so we will use the same thing, stat basic statistics, two sample t-test. Okay, are you there?
Yep.
So can you see this? Oh, you might have the drop down.
I have the drop down.
You have the drop down, right? So samples in different columns.
Okay.
Okay, so let's select less than 1 year and then greater than 1 year. Click on assume equal variance. And in options,
I don't have that. Is that in options? Oh, there it is. Okay.
Okay, and then in option, keep alternative as not equal.
Okay.
And then click on OK. You can actually go to graph and plot a box plot as well. Yep. Why don't you look at the p-value? Now, before that, can you look at the box plot?
Yep, I'm looking at it.
Right? Do you see, there's a great deal of difference,
Mm-hmm.
right? So, at one glance, visually it tells you, what is happening. Associates or agents with tenure greater than 1 year, their AHT is quite low,
Mm-hmm.
as well as the variation in the AHT is also very low as compared to agents with tenure less than 1 year.
Right.
Right? So straight away we know that tenure is a factor. Okay, let's go to the session window. So can you look at the p-value and let me know what is your interpretation? Which hypothesis and what does it mean?
P-value is 0,
Mm-hmm.
which I've never seen before, but okay, I can deal with that. It's good data.
Okay, so
if
there
you
in
alternate,
statistics, so in statistics there is no good or no bad,
yeah, alternate.
right? So,
Yeah.
yeah, in alternate hypothesis, what does it
Yes.
mean?
What does it means? Yes, it is valid data, and there is a significant difference.
Yeah, there is a significant difference.
Yep.
So now that you're becoming half statistician, you start speaking that language.
Yes.
Right? So there exists a significant difference between the mean of both the samples.
Mm-hmm.
Right? So if we are
Right.
trying to test whether tenure is a significant factor, yes, it is a significant factor because there is a significant difference between tenure of people less than 1 year and greater than 1 year. Okay, so we have proved one of the potential X as this has come out to be a vital X for us.
Mm-hmm.
Okay. Now let's look at another one. So in the first test we we compared one sample with a targeted value. In second test we compared two samples with each other. Now what if we have more than two samples? Okay, so if we have more than two samples and we want to compare, we would use a test which is known as one-way ANOVA. The concept remains the same. So all these are called ANOVA family tests. So ANOVA, what ANOVA would always do, they would always compare the mean of whatever number of samples that you have taken with each other.
Okay.
It will compare mean of all the samples. Okay, and again it is a mean based test. Okay, so let's look at, do I have the data on one-way ANOVA?
Yes.
Okay.
Yeah, I saw that in my email. Yep.
Okay, so Scott, it seems you're on your own on this one. I'm not able to open it.
All right, just walk me through it. I got it put into the mini tab.
Yep. Okay.
Okay.
So the path is same. Stats, basic statistics. Somewhere there would be. Oh, sorry. It's gonna be in quality tools. Stats ANOVA, one way.
That's ANOVA one way. All right.
Okay. Do you get something like this? Response and factor?
It's
or
similar.
but you have the
I got
drop
a
down?
drop down. Yeah, I got a drop
Oh,
down that
see,
response
that's the latest.
data.
That's the latest version, right? So, what
Yeah.
I would have to do is I would have to stack both of these in one column.
Oh no, that lists them all out for me when I say separate columns.
Oh, okay. So that's the change
And
I've done.
I assume I can just I can just click them all and drop them in
Okay.
there.
All right. Perfect. So these were the changes I was talking about. Not worth $1,200.
Yeah.
I can stack them. Okay. So did you run the test?
I put them all in there. Do I want to do anything with options, comparisons, graphs, anything like that?
Oh, you can do the graphs.
Interval plot
You can do
or box
anything.
plot?
Yeah,
Okay.
you can do box plot.
Oh, we'll do that. What the heck? All right, here we go. All right, I got a nice, pretty box plot that is showing Monday, Tuesday, and Wednesday pretty much even, and then it drops off for the rest of the week.
Mm-hmm. All right. Okay. So you go to the session window and see if there. So what it is doing is it is comparing data for all the weekdays and seeing if there exists any difference between the mean of AHT for a particular day of the week. So are we saying for
Right.
a Monday or a Tuesday, does weekday have any impact on the average handling time?
Yeah, it looks like
Go
Monday,
ahead.
Tuesday, Wednesday are pretty within 3 minutes of each other, or three, and then it drops.
It drops. Yeah. So people get more relaxed on Friday.
Yeah, I guess. They don't want to talk at all on Saturday.
Right.
Standard deviation drops as well. But there is no p-value. Am I supposed to have a p-value?
Or is there no p-value? There should be.
Is it pooled standard deviation?
Nope.
That's my
Full
p-value.
standard deviation. No. P-value would be somewhere over there.
Let me look. Did I scroll down to the means and miss the? Okay. Okay. I just scrolled through it. Probably.
Oh, okay.
Factors. Analysis. mean.
So there must be a p-value right at the top. The first table.
First thing says method, and it basically says null hypothesis, alternative, and significance level. So just assume it's just giving me the rules because that's what they look like.
Mm-hmm.
And then it's factor information, analysis, variation, variance.
Does it give you one way ANOVA table? Okay.
I found it. P-value 0. Yeah, it's got a bunch of stuff that one doesn't have.
Right. So p-value 0. What does that mean?
It means it's an alternative hypothesis, and means the data is good to use.
Okay, data is good. We found out during MSA, but here, data is good or bad, we don't know, right? And we really don't care. What we want to find out is, is day of the week, does it have a significant impact on the average handling time?
It does.
So it does.
The day of the week is true then. Right.
Yes, so day of the week has got significant impact. So we would need to, so remember right now what we are trying to do, we are trying to validate all the factors, right? So
Right.
we have a bunch of factors, and we are trying to run the test, and we want to find out of all the factors that we have, which ones are significant, right?
Okay.
So at the end of analyze phase, we need to have a list of all the factors which are significantly impacting the product Y. And then in the improve phase, we will then devise a solution for these factors. Okay.
Okay.
So what we found out, what we did is we did 3 tests. We looked at 1 sample T, 2 sample T, and 1 way ANOVA. 1 sample T when we wanted to compare the sample with the targeted value. 2 sample when we wanted to compare 2 samples with each other, and 1 way ANOVA when there were more than 2 samples. So in your project that you did, there were 12 locations. If you wanted to compare the average handling time of all the 12 locations, which test would you use out of these 3?
One way ANOVA.
Absolutely. 1 way ANOVA would tell us if there exists a difference in the average handling time of each of those 12 locations, right? So by looking at the data, you would be able to find out which location is pretty high on AST, right? So that you can go there and tell them that your performance level is pretty high and what might be the reason. Sorry, pretty low, what might be the reason. Okay, so this is the mean weight test. These are called comparative tests, because what we are trying to do, we are trying to compare with each other. Okay, let me just go back. You're still there, Scott, right?
Yep, I'm still here.
Okay, right. Same thing you would see in the presentation. We'll not go through it because since we have practically done it now and we know how to go ahead and run the test. Okay, let me just show you something in Minitab.